Time is something that everyone is familiar with. 60 seconds is 1 minute, 60 minutes is 1 hour, 24 hours is 1 day, and so on. This is known as linear time and is something that everyone is familiar with and agrees upon. But consider this. If someone came up to you on the street and asked you to draw time, what would you draw? You might draw a clock or a watch ticking every second, or you might draw a calendar with excess over each day to represent the passing of two. But that's all those drawings would be, just physical representations of the passing of time. Those drawings would just scrape the surface of the enigma that is time. Something that seemingly runs our lives and is unavoidable, can't be explained by even the smartest people on Earth. So what is time? And can we prove that time even exists? Aristotle once said time is the most unknown of all unknown things. That was nearly 2,500 years ago. And it still stands true today. If you were to go to Google and type in what is time, you would find that it says time is a dimension. And in many ways, it is when you text a friend and ask them to meet for coffee, you wouldn't give them a place without a time. However, there's a flaw in that definition of time. It leaves too many doors unopened because time is also a measurement. For example, I was born in the 1990s, that was over 20 years ago. If I were to say I was born 18 billion kilometers in the past, that wouldn't make much sense. And people would probably look at me like I'm crazy with spatial dimensions. The 3D world that we live in, it's very easy to go back and forth between places, because these things are essentially fixed in space. If I went to the store to buy groceries and I forgot milk, I could easily go back and buy some milk. However, the time that it took to do that is unable to be retrieved. It is lost forever into the past. An object placed in 3D space will stay there almost indefinitely. If I place a bottle on the table, it will just stay there, but that bottle still falls victim to time. See, time is like an arrow, it moves in one direction forward. Scientists fittingly call this the arrow of time. If you one day woke up and found yourself floating in the middle of empty space, would you be able to tell which way is up, down, left, or right? Probably not. However, time is a much simpler ordeal. See, time comes from the past, originating at the Big Bang where our history lies and is fixed, through the present, where we are essentially prisoners of, towards the unknown and turbulent future. We can remember things from the past. Like how I can tell you that this morning, I went to the store, bought groceries, and then forgot to buy milk. But at the same time, I can't tell you what I ate for breakfast. Next Thursday, the arrow of time originated at the Big Bang, and has been moving forward ever since. We use the second law of thermodynamics to represent this. It is known as entropy. Think of entropy as a measure of disorder in the universe. At the Big Bang, all the matter in the universe was compacted into an infinitely small point. This is considered a very low entropy situation, a very orderly situation. It would be similar to stuffing every sock that was ever made into one drawer. In that situation, you know, with 100% certainty where your socks would be. Ever since the Big Bang, all the matter in the universe has been expanding away from each other, making the universe a higher entropy system because of entropy. And because of the arrow of time, we have galaxies, stars, planets, and even life. Entropy is the reason that you can tell the difference between the past and the future. It explains why every human is born, and then lives and then dies, always in that order. If there were no entropy, if there were no change in the universe, you wouldn't be able to tell the difference between the year 2017 and the year 1 billion. No matter what you do, time moves forward and doesn't stop for anyone or anything, at least on the macro scale. See, the arrow of time works and is extremely noticeable on large scales, the scales that you and I operate on every day. But at a quantum level, time operates differently. Take the situation where you woke up in the middle of space there, you have no idea which way is up, down, left, or right. It's a very unique situation that only applies in the vastness of empty space. But if you come back to Earth, it's very easy for you to orient yourself. The arrow of time works in a similar way on a macro level. The big level, it's very easy for you to tell that the year of 1900 is different from the year 2018. It's very easy to view the flow of time. However, on a micro scale, if we look deep down into the physics that make up the universe, entropy, and subsequently time isn't so obvious. If I were to record myself cracking an egg and pouring its guts into a bowl, and then I reverse the footage, you would easily be able to tell that the footage had been reversed. However, if I record a pendulum swinging back and forth for 5 minutes and then reverse the footage and show it to a random person on the street, will they be able to tell that that footage has been reversed? The answer is probably not. See, the arrow of time seems to flow in one direction on the macro scale. But as you take parts of it away and skim it down to the bare bones of particles that make up the universe, time seems to work and flow in every direction, both forward and backward. There are no laws of physics that states the past is any different from the future. The only reason why you can think about what you want to have for dinner tomorrow, as opposed to what you want to have for dinner yesterday, is because of the arrow of time, because of entropy, because the universe had a beginning, or at least it seems like it. You might be starting to see why the arrow of time and entropy are so important. They quite literally govern our lives, and the universe see the fact that entropy is increasing is well known. It's the reason why life today is the way that it is. However, not many people are addressing the question. That is, why was the entropy of the universe so low in the first place? Well, the answer is simple. It was lower yesterday than it was today. You can take this logic all the way back to the Big Bang. You hear that a lot. The universe came into being at the instance of the Big Bang. And for all we know as of now, that may be true. However, it might not be true. We have the physics of Einstein's general relativity that allow us to go back to mere seconds after the Big Bang. But after that, our equations break down. That's as far as we can go for. Now, there's no law of physics yet that states that there wasn't time before the Big Bang, and perhaps a reversed arrow of time. We just don't have the science to look that far back yet. In a previous video of mine entitled, The End of Our Universe, I discussed the situation that may occur in the distant future, because the universe is expanding, and because entropy is increasing with time. There will eventually be a time where everything in the universe is so far apart from one another that space will essentially be empty. Everything will be too far apart to interact with one another, all the way down to the atoms that make up everything in the universe. However, just as the temperature outside fluctuates day to day, so does the entropy in the universe, albeit very small fluctuations over small time scales, such as a human life, over unreal time scales, such as 10 to the 10 to the 10 to the 56 years. It is possible that quantum fluctuations could cause an extremely random extreme entropy decrease. This would create conditions similar to the Big Bang as we know it, and could explain the arrow of time and the origin of our universe. However, in order to answer these questions, we need to unite quantum mechanics with Einstein's general relativity. This would provide a scientific link between the quantum world of atoms with the macro world of stars, galaxies, and black holes in the universe. This is dubbed the theory of everything and is something that many scientists are working on right now. With this theory, we may be able to, for the first time, be able to explain how and why the universe we live in came into existence, and maybe even prove that the multiverse exists. If you'd like to help in finding a theory of everything, and go down in history as a scientific genius, then you'll definitely need to study up on relativity as well as the quantum world. You can do both of these things over at Brilliant. Brilliant has tons of online courses on subjects such as special relativity and quantum objects, all the way to calculus and group theory. These courses are actually fun and interesting to go through, unlike your boring math class in school. Brilliant shows you exactly what you need to know and why you need to know it, without interjecting a bunch of boring and useless information in between. You can learn about some of the most challenging topics and ideas, and end up with a really good understanding of any subject in as little as 30 minutes. If you'd like to learn more about the world of math and science and support the channel, at the same time, head over to Brilliant.org/aperture and start learning about topics that I covered in this video. Today, the first 200 people to go to that link were 20% off of a premium subscription. This video was made in collaboration with the YouTube channel Question. All the animations you saw in this video were created by them, and I'm extremely happy to have worked with them. They actually make great science content much like I do and are relatively unnoticed. Their link is in the description below. Be sure to leave a comment letting them know I sent you. I'll be making an appearance on their channel very soon.